Hello, my name is fmckenna. I'm here at the UC Berkeley working for the Sim Center. In this video, I'm going to do a short C++ class example to introduce you to the concept of classes in C++ and how we code them. It is a very simple class. It's a class example for colored shapes. We're going to have what will be shown to be an abstract class. I will explain why this is an abstract class. The abstract class defines a number of methods. In this demonstration, I'm going to show the implementation of two classes. We're going to have a rectangle and a circle. The circle class I'm going to demonstrate in the terminal. The circle itself, it's going to only implement one of the methods in its parent class, so it's going to override the getArea method. The circle itself is going to have a variable r, and it's also going to have a private function pi. Area in green is not going to be accessible to anybody outside of a circle. It's inside the shell of the egg, so nobody from the outside world will be able to see the r and the get pi in a circle. We're also going to look at a rectangle. The rectangle is going to override the print and getArea methods. The rectangle itself is going to keep two variables, b and d. Again, they're going to be hidden from the outside world, so nobody will be able to see them. So now let's look at the header file for the colored shape. So as typical in a header file, we want the if nodef, define, end if. There should be an I in define. This stops circular inclusions, which would cause the compiler to go into an infinite loop. We're going to include this string file, and we're going to include the statement using standard string. What this does will prevent us from having to write standard string everywhere we see a string. So here is the class definition, the keyword class, followed by the name of the class that we are going to define. So in this case, the type of class we're going to define is a colored shape. We have a public section. The public section is what is available to the outside world. In this case, anybody in the outside will be able to invoke getArea, print, and getColor on an object of type colored shape. The class has some private area. Inside the private area, we're going to keep the color inside a string type. Now let's look at these methods. The important one to note, the colored shape, this is what is called the constructor. The colored shape's constructor takes one string, which is going to be the color variable. Colored shape has a destructor. Very, very important when you're defining an abstract class or any class with virtual methods that you define the destructor as also being virtual. This will ensure that it can actually this method can be invoked. Two other virtual methods, we have getArea and print. The difference between the two is getArea has this equals 0 at the end of it. This defines this as a pure virtual function. The presence of a pure virtual function in a class definition means that that class is an abstract class. What an abstract class is a class of which an object cannot be constructed. In our main program or anywhere in the code, we cannot construct an object that is purely of type colored shape. It tells the compiler we must invoke or create an object of a subtype, and that subtype must have a getArea somewhere in its hierarchy. Private again to the colored shape is the color, which I'm hiding in a string. Accessibility, quickly go over this. Anything that's in the public area can be looked at and seen by any other piece of code. Protected is an interesting one. So if I had an area here that was protected, any subclass can use the methods and variables defined in a protected area, but no other type of class can use that code. And then private is limited to the class itself. So anything in private is only available to this particular class. Not even the subclasses can see this variable. If the subclasses need to get the color, they too have to come through this method that's in the public domain. So I believe I've covered everything on the right. You can read it yourselves, see if I've missed anything. So now we're going to have the rectangle. So I'm up above, I'm keeping this just for reference. So here's our rectangle. The rectangle is a class. We have our colon here, and then what we're saying it's a subclass of ColoredShape, and it's public. So anything that's public here is also public in Rectangle. Like the ColoredShape, it has some public methods. It has a constructor. The constructor for a rectangle takes a string being the color and two doubles being the width and the height. It has a destructor. It has a getArea method. If you remember, the getArea was equals to 0, which made this one an abstract class. Here we're actually providing an implementation. This will allow us in the code to actually create a rectangle. And then we are overriding the print statement that is in the ColoredShape. I forgot to mention this, but because this is defined as virtual in the ColoredShape, it means we can override it. Anything that's not virtual in the parent class, we can't override in the subclass. This class has protected area, but there's nothing in it. And then it also has some private area, which we're squirreling away width and height. We're also squirreling away a static integer named numRect. A static integer is something unique to that class, whereas this width and height, they're unique to every object. So when we create each object of type rectangle, they will have their own width and height, but they will all share this numRect. So all the rectangles will be able to see how many rectangles they are, but each one will have its own unique width and height. So that's the rectangle. So now let's look at the C++ file for our ColoredShape, the implementation of ColoredShape. So before we have every class, we're going to have this the class name and a double colon. That indicates that this is the implementation for this class. So ColoredShape's constructor, it takes one string color, and we're just setting color directly in the constructor. This colon allows us to set any of the variables directly without having to do it in code. I could also do it in code by setting color equals to col, but this is the quicker way to do it. We have the destructor in this case, and you'll see why later. I'm just sending a message to standard out that the destructor is being called on a shape. Finally, we have the getColor method. It returns a color. It's returning a constant string reference, which means nobody, once they get this reference, can change the color. So everybody can ask an object for its color, but nobody can actually change the color. And then finally, the shape is going to have its print method, and it's going to output to the stream that it doesn't know the shape, it's unknown shape, but its color is color, and its area it gets from itself. So nowhere in the header file have we defined this. This is always there and always available when you're writing a class's method. This refers to itself. So this on anything refers to the current object. So this getArea will get the area of the current object no matter what it is. Okay, let's look at the rectangle. So here we have the Rectangle.cpp file, which is the implementation for the rectangle. First line, this is where we are initializing that static variable that was shared among all the rectangles. So it's int rectangle : and then we're assigning it equals to 0. This is the destructor for rectangle. We have that. So this is the Rectangle.cpp file, our implementation of a rectangle. First line, we are initializing that static variable shared among all rectangles. This is how we initialize it. We have the rectangle : before the variable name. We're assigning it equals to 0. This is our destructor for a rectangle. We are decrementing that integer, that static integer, by 1 and spitting out a message. Again, we will see why I'm doing this when I run the program. Now we have our constructor. It takes a color in a string and the width and the d in two doubles. This is where we pass that color to the constructor. So here we're invoking the constructor. with that string. If you go look at the colored shape, it took a color in the constructor. This is how we pass it. Then we have the width and the height. We're setting the width variable and height variable equals to W and D, and then we increment the number of rectangles. We have the getArea method, which just returns the width times the height. And also we have this print method. The print method is printing out that this is a rectangle, its color. The color it's getting from itself, this.getColor. This.getColor will find the color, the getColor method in the parent class. I'm actually missing here two angle brackets. They're in the source code. And then we're just outputting the area, width times heights. And we're also outputting the number of rectangles. So now what I thought I would do is, in the terminal, show you how the .h and the .cpp file for a circle. So here I am in terminal. I'm in the directory ColoredShape. ColoredShape has my colored shape file and my rectangles. I also have a main here and a CMake lists. So first of all, I'm going to create a circle, a .h and a .cpp. I'll add it to my CMake lists and see if it builds. And over here on the right, I'm just reminding myself what a circle is supposed to do. So let's begin. So we're going to make a circle class. The first easiest way to start off making a class is just copy something that's close. So I'm going to copy rectangle, and I'll copy the CPP file as well. So now I have two files that are the same. I'm going to Emacs my circle.h. Okay, I'm going to replace rectangle with circle. I should have done a global replace. Let me do that next time. So I'll escape. Less than sign takes me to the top of the file. I will hit escape, %. I will replace rectangle, REC. I will replace it with, RECTANGLE with circle. So just yes. Oh, I get out of that. Let me just circle. Circle is only going to take an R, a radius. Circle has an R. We're doing the get area, but we're not doing the print area. Circle, replace these two variables. We've only got a variable R. We're not going to have any static variables. So we have a function int or double get pi, and we'll say that's a void to return pi. This is a real stupid function. I just want to demonstrate a private function. So that looks good for our circle. So again, circle is a subclass of ColoredShape. It's got some public methods. The only public method it has, we have a constructor or a destructor and a getArea. Okay, it has no protected data, and it has some private data R and this protected function. So that's our circle. So now we will Emacs a CPP file. We'll do that global replace again, escape, %, RECT, I don't know what, CTANGLE. Circle. And now I will hit exclamation, so I will do them all in the file. So the exclamation did them all. I didn't have to do one at a time. So let me go back to the top of the file. So that's escape, less than sign, and just we now have no static variables. So this is no good. We'll leave that method in. Circle, color and an R. We'll say it's radius. Shape. This is radius. And R. Colored shape. The call to the constructor is right. You know what? Let me demonstrate. R equals radius. I could also do this here. I don't have to do it in this special spot here. It has an area. Area is R times pi. R times, we have to invoke get pi. You know, this is just for demonstration purposes again. There's no print area method, but there is a get pi, which I believe took a void. It was called get pi, and it is of course going to return a double. So let's just return 3.14159, say. Okay, that looks good. So let me just Control X2 to see I've got everything right. So Control X2 splits the screen in two. Control XF, I will bring in the circle.h. So the radius, string color, it is R, and we do have the function get pi double void, so that should work. So we have that now. So now I'm going to edit that CMakeList file. So what is a CMakeList? What have I done? We have Rectangle.cpp, Circle.cpp. So we're going to create a little library called shapelib, in case, because might create multiple main files. So I'm going to put everything that's shared among the main files in a library, and then I'll just link the main with the library. So here's where I link for each executable I create. I'm going to have to do this. But basically now we've added circle to my CMakeList. I'm going to cd into my build directory. It's always a great idea. It's pretty much standard that you build everything in a build directory off the main directory. So let me cmake ... I have no errors. Let me make. Okay, it worked. So if I run this now, I have this. It's called EX1. What have I got in EX1? I probably know circles. I've just got a rectangle. So now let me, I will Emacs the main file and put in a circle. Main1.cpp. So as you see, I've been in here before. So let me create a circle just to make sure this works. And I'm going to print the area of the circle. Notice in this file circle, I'm invoking the constructor directly, whereas for the second shape, S2, I'm actually using the new function that's in C++ to construct a rectangle. So let's build that now. Oh, didn't like circle. Didn't like circle because I don't have it in that header file. So I've commented this out. So I've now included the header file. So that was the error message, unknown type circle. So that told me right away I'd forgot to put in the header file. So let me make again. And what does it not like? Oh yes, I've got the color. No, go away. So let me Emacs that again. Circle, I'm only providing the radius. I did forgot to put a color. So make the color. I think the color was the first one in this one. Okay, there's color. Let's look again. What did I do wrong this time? Let me look at a circle quickly. Ctrl+XF, circle. Yeah, the color and the R are just reversed. Should have known because that was the rectangle had the colors. And I copied from rectangle. Print area. What's the matter? I got the wrong print area method. Let's fix these up while I'm at it. And this new rectangle, these guys are going to need a color as well. So when I uncomment them, let's make that guy blue. And we'll give a pink one for my youngest daughter who loves pink. They're still commented out. There we go. We should see a little bit different. So now we're seeing the destructor. So getting that destructor out. So there's my green. Remember, it's unknown because I haven't got the unknown. I'm using the print method in the colored. I didn't actually provide a print method, so it's invoking the class above. It's finding the method in the class above, but it's actually printing out the area 2 times pi. And then we have the color red, and then the circle destructor is getting invoked. Okay, so that's that done. So let's go back to the presentation, and we'll talk about these structures getting called and stuff like that. But let's actually, while we're here, just delete the, remember when we do a new, we need to do a delete. We don't use square brackets because we didn't create an array. So we're going to delete S2. We're going to build that. Now we're going to have a look at so the rectangle's getting destroyed. Let's have a look at colored shape here a second. Let's look at colored. Yeah, there's that. I've got multiple. This is why that multiple things are coming out. So we just have one. We'll make that. So it'll be as the exact we're getting in the example. EX1. So the rectangle, then we get the colored shape destructor. The circle's getting destroyed, and then we have the colored shape destructor again. What I want to point out in the presentation is the order in which these destructors are called. Okay, let's go back to the presentation. Here I am back at the presentation. So this is what we just went through for the circle, the .h file, the .cpp file. I made a little error in my demo. You know, radius of the area of a circle is pi r squared. So now let's change tacks. Let's look briefly at the STL. So the STL provides some data structures. Those data structures, such as lists, stacks, arrays, etc., provide a bunch of container classes and algorithms and iterators for you to use in the program. And I'm just going to demonstrate with one. I'm going to use the list. So this list was similar to what we did yesterday with the points and the elements. We showed them in a linked list. Well, this list STL gives the exact same thing. So the way to create a list, I'm going to declare a list of shapes, and this is the way we do it. It's standard list. In the angled brackets, we specify the type of object it's going to hold. In this case, it's a pointer to a colored shape. I construct my circle. My 2 rectangles. I'm then going to add my shapes now to the to the shapes list. So it's, you're going to push them onto the front of the list. Because I said it's taking a pointer, I have to put in the address of shape 1 because shape 1 was constructed without using a new. And then I push on S2 and S3. And then to print out the colors, I have to iterate over the shapes, go from the first to the last. And I use this is the format here. I have to create an iterator to do so. I iterate from the beginning of the shapes, while the iterator is not at the end of the shapes, and I iterate plus plus. I'm going to print area on the current iterator. That's a little bit ugly. Again, we have typedef to the rescue. So here it is with typedef. So I typedef, I do a typedef for container. I say it's equal to this. This is my alias for standard list colored shape pointer. So then I can also do typedef on the container. For the typedef, I create an alias to iter, which is a container : iterator, and then I can use container. I can say the shapes is now just a container. I can add the shapes push, and then I declare an iterator it, and then I just run through that, and I put it to you that looks slightly cleaner than this stuff here. So with that, I'm done.